Welcome to the AI Coach by Anil Nathu. Today, we are undertaking a really critical deep dive into one of the most hotly debated and I think potentially revolutionary pieces of technology to come out of Google in a long, long time, Google Antigravity.
We have a huge stack of sources here. I mean, everything from Google's own technical white papers to, raw developer feedback threads, security analyses. And our mission for you, the listener, is really clear. We want to give you a definitive shortcut to being well-informed on this.
So you don't have to read all of this.
Exactly. We need to dissect the core concepts, the architecture, the controversies, and of course the future implications of anti-gravity. And we have to position it within this just massive disruption of the AI IDE market that's happening right now.
Okay, let's just jump right in and unpack this. This is not another incremental improvement. It's not, a slightly smarter autocomplete, thank goodness. The big idea here, the fundamental hook, is this profound, almost philosophical shift in how we do software development.
It really is.
We're moving from AI acting as like a passive assistant to these truly autonomous, proactive AI agents that are designed to handle entire development tasks, from the idea all the way through to verification.
That is the seismic shift. And it's exactly why anti-gravity has captured so much attention for, decades? The developer has been the meticulous constructor, detailing every single API call, every variable.
Every line.
Every single line of code. Anti-gravity just completely changes that role. You, the developer, you transition, you become the architect, the strategist, really the conductor of an orchestra of these autonomous AI helpers.
So you're moving from the nitty-gritty to the high level.
Precisely. It's a necessary transition from focusing on the construction details to focusing on the high-level direction and the outcome. And, understanding this change, it isn't just about a new tool. It's about shifting your entire career mindset. And that kind of strategic pivot is exactly what resources like the AI Coach by Anil Nathu are designed to help you navigate.
Okay, so what does this all mean practically for you listening right now? We're going to structure this deep dive to give you as much clarity as possible. First, we have to define the platform. What actually is Google Antigravity, and how does its mission control interface completely change the game? Then we'll pop the hood. We'll look at the very structured four-stage process these AI agents follow, and of course the Gemini models that are powering it all. After that, the strategy. How did Google spend billions to get here? And finally, we're going to tackle the really messy current reality. The cheers, the jeers, the stability problems, and some extremely serious security and ethical pitfalls that, they popped up the moment this thing hit public preview.
Yeah, that part gets interesting.
Let's start right at the beginning with the definition that Google itself is pushing. When we talk about Google Antigravity, we're talking about an agentic development platform. Agentic. It's a word that implies a degree of independence, right? Proactive thinking. What's the real practical difference between just a coding assistant and an agentic partner?
Well, the difference is all about initiative and scope. A standard coding assistant, think GitHub Copilot, it just responds to what you're doing. It suggests the next 3 lines based on the 5 you just wrote. It's passive, it's reactive.
Right, it's waiting for me.
It's waiting for you. An agentic development platform, on the other hand, it uses these agents that are designed to take a high-level objective, something like implement oauth login using Google's API, or even refactor this entire class for better memory efficiency.
So a whole project, not just a line.
A whole task. And it will autonomously strategize, execute, and then verify the entire multi-step solution. They are proactive partners, not just passive tools. The developer in this model isn't writing a line of code to start. They're defining the grand design and then delegating the actual labor to this specialized, persistent AI team.
That transition from being the person who's meticulously placing every single brick to being the general contractor, it's fascinating. Right. And it has to demand a completely different workspace, which is what Google is providing with this dual interface approach. Let's start with mission control. They also call it the manager surface.
Right. And mission control is, it's literally the command center. It's the conductor's podium where you manage this distributed team of AI agents. And crucially, its function is management and orchestration, not execution.
What does that look like?
So imagine you get a large feature request. Instead of diving into the code yourself, you go to mission control and you might spawn 3 separate agents.
Okay.
One for the back-end logic, one for the front-end UI updates, and say a third one just for documentation. You assign each one a complex objective, define its goals, and then you just monitor their progress.
asynchronously.
Asynchronously. That's the key word there. Because in the old model, if I walked away from my IDE, nothing happens. Now you're saying the work just keeps going. Exactly. It keeps going. You are constantly observing, reviewing, guiding, but the agents are running tasks in the background. They're independently querying APIs, running tests, writing documentation. Mission Control gives you the visibility. It's a dashboard showing all the current tasks, which agents are spawned, their status.
Well, I can see what they're up to.
You can see everything, and you can intervene, but only when you need to. Like if an agent hits some unexpected roadblock or comes back with a flawed plan, it's a shift that profoundly changes the daily rhythm of development. It moves your focus from typing to high-level strategic problem solving.
Which brings us to the second interface, and this is the one that's designed to make people actually adopt it, the editor view. This is built on a fork of Visual Studio Code, or VS Code. Why was that architectural choice to use a fork of the market-leading IDE so vital for Google's strategy?
Oh, it was an absolute necessity for market penetration. I mean, look, developers are creatures of habit. You spend years refining your IDE setup, your key bindings, your extensions, your muscle memory. If Google had tried to force developers to abandon all of that for some completely proprietary new environment, it would have created an insurmountable adoption barrier. Nobody would have used it.
It would have been dead on arrival.
Totally. So by forking VS Code, Google essentially said to the developer community, hey, keep your custom theme, keep your favorite linter, keep your debugger. We're just bolting a revolutionary new engine onto the chassis you already know and love.
So it just massively eases that transition.
Immensely. It ensures that the millions of developers who are already fluent in VS Code can move into this agentic world with really minimal initial friction. They keep access to that huge ecosystem of VS Code extensions, their customizations, and that lets them focus their energy not on learning a new interface, but on mastering this new complex skill of orchestrating AI agents.
Yeah, that detail, the familiarity of the VS Code fork, that's probably what gives it a fighting chance for widespread adoption, even if the underlying AI is so revolutionary.
It's the Trojan horse.
Right. So we have the platform, the command center, the familiar editor. Now let's get into the structure. Let's open up the engine room. How did these specialized helpers actually execute the complex jobs they get from Mission Control?
This is really where Antigravity separates itself from the more passive tools. It's not just about the output. It's about a structured, auditable process. The agents follow this very clear four-stage cycle that ensures consistency, efficiency, and maybe most critically, auditability.
And stage one is plan. Why is planning by the agent so much more important than, say, a human developer just jumping in and starting to code?
Because planning is where you guarantee efficiency and you contain scope creep. The agent doesn't just, jump into execution based on a vague prompt. It first formulates a strategic outline of steps.
Can you give me an example?
Sure. If you ask it to add feature X, the agent first comes back with a plan that looks something like: Step 1, create new branch. Step 2, write unit tests for feature X. Step 3, implement core business logic and file Y. Step 4, run integration tests. Step 5, generate documentation. And the developer reviews and has to approve that plan before any code is executed.
So there's a human checkpoint right at the beginning.
A critical one. This strategic outline prevents the agent from just going down some inefficient rabbit hole, and it makes sure the approach is considered and sound before you waste any time or tokens.
That immediately makes the developer's role one of strategic review, not tactical execution. Okay, so once the plan is approved, we move to stage 2, execute. You see, this is where the multifaceted nature of these agents really shines.
It is, because the execution stage is so broad. These agents are not just confined to the text editor in your IDE, they're versatile. They operate across the entire development stack.
So more than just writing code.
Oh, much more. They write code, of course, but they also run commands in the terminal to execute tests, spin up local servers, they can interact with external APIs to fetch schemas or sample data, and if you tell them to, they can even perform actions inside the browser.
What, like clicking on things?
Yes, simulating user interaction to verify UI changes. They really are performing tasks across all these varied environments, mimicking how a human developer bounces between Windows and terminals all day.
That's incredible. Okay, stage 3 is where you build trust. Verify. And this is the much-hyped, artifact-driven verification. This sounds technical, but why are some sources calling this the genius element of the whole system?
Because it directly solves the black box problem that's inherent in these large language models. Historically, an AI coding assistant just spits out the final code and you just have to trust it. Artifact-driven verification forces the agent to generate transparent evidence. They call them artifacts of every critical step it took.
Okay, let's get specific for the listener. What does an artifact actually look like in the interface? Is it a file? A log?
It can be a whole variety of things. It could be a successful green check mark from a unit test log that it ran in the terminal. It could be a timestamp screenshot showing the new UI element rendered correctly in a browser. Maybe a recording of the agent interacting with a third-party API and getting the expected response back. Or it could just be a trace log of all the changes made across different files.
So it's an auditable paper trail?
It is an auditable, verifiable record of its actions. So when the agent submits its finished code, you don't just review the code diff, you review the artifacts that confirm the process was sound and the goals were actually met. This level of transparency makes giving feedback so much simpler, and it helps you verify the integrity of the process itself, which is just vital for getting people to adopt it.
Right. So trust is built through evidence, not just assuming it works. And that evidence then feeds directly into the final critical loop. Feedback.
Precisely. The feedback loop is what drives the system's long-term improvement. Developers give direct feedback on the submitted code and the artifacts. They might reject a step and tell the agent, look, your unit tests are comprehensive, but this function name violates our internal style guide. Fix it.
And the agent learns from that.
It guides the agent's future actions and allows the platform's underlying models to adapt and improve their performance and their adherence to your specific organizational standards over time. It's how these autonomous helpers evolve from just being basic coders to being specialized integrated team members.
This whole structure, it just sounds like it requires immense computational horsepower.
Yeah.
What specific AI is Google using to run this complex orchestration?
Well, the engine room is powered by Google's most advanced foundational model. So we're talking primarily Gemini 3 Pro and some other specialized Gemini 3 models. This immediately puts anti-gravity right at the forefront of generative AI applications. It's leveraging Google's massive investment in model capability, context window size, and reasoning.
But, and this seems really smart, they didn't make the huge strategic error of locking users into only Google's ecosystem. The inclusion of multi-model support is a massive competitive feature, isn't it?
It might be the smartest competitive move they made. By allowing users to integrate and use models like Claude Sonnet 4.5, Claude Opus 4.5, and even OpenAI's GPT-OSS, they completely mitigate the risk of vendor lock-in.
Which developers hate.
Despise. This flexibility means you could choose, for instance, a model known for superior reasoning, like Opus, just for the planning stage, and then a model known for really fast, efficient code generation, like Sonnet, for the execution stage.
So you can mix and match for the best result.
Exactly. It ensures developers can choose the best AI tool for a specific task, maximizing the utility and making Antigravity feel like a truly open platform, even though it's a Google product.
That makes total sense. It's like an agnostic layer managing the workflow, no matter what the underlying computational brain is. That's a powerful selling point. So now we know what it is and how it works. Let's pivot to the timeline. How did Google get from that old passive coding landscape to staking this revolutionary claim?
Well, the landscape before Antigravity, it was dominated by these simple suggestion engines, tools that were helpful for sure, but they were fundamentally passive. Google recognized that the next frontier wasn't just better suggestions, it was full autonomy. And to get there, they used a very aggressive and deliberate acquisition strategy.
And let's focus on the scale of that ambition. The source material points to a specific date and a, frankly, staggering figure. The July 2025 acquisition of Codium Windsurf technology and talent for $2.4 billion. That's not a small feature purchase. That's an attempt to buy market dominance.
It was an emphatic, strategic commitment to building a next-generation agentic coding platform. The $2.4 billion was less about their existing product and more about just accelerating their own timeline by acquiring seasoned talent and proven infrastructure that was already focused on code acceleration and efficiency.
So they bought the team and the tech.
Right. Codium was known for its rapid suggestion speed and deep integrations. Google basically took that foundation, fused it with DeepMind's agentic research, and created Antigravity. It was a signal that speed, efficiency, and agentic capability were now the core tenets of Google's vision for software development.
The public rollout came pretty quickly after that massive investment.
It did. The grand unveiling was on November 18th, 2025. Google Antigravity hit public preview, and it was strategically timed to coincide with the launch of Gemini 3. This was meant to signal that Antigravity was the flagship application for their new generation of models.
And they made it available everywhere at once.
Immediately. Mac OS, Windows, and Linux, ensuring maximum reach from day one.
The initial offering was pretty generous, right? It was designed to lure developers in, but the business model friction became immediate and very controversial.
It really did. While the initial free offering for individual users was, highly generous, the transition to a tiered system with rate limits was swift and, for early adopters, pretty painful. These agents, just by their nature, are resource hogs.
How so?
Well, all that planning, executing, running tests, generating artifacts, it just consumes a massive amount of tokens. So Google very quickly introduced these stringent weekly caps on free users.
Can you elaborate on what that friction actually felt like for a developer? If I'm a free user, how quickly do I hit that wall?
For developers working on any kind of complex multi-file project or using the agents for a major refactoring task, they were blowing through their credit limits and token limits within days, sometimes, within hours of the weekly reset.
Okay.
So suddenly, this revolutionary tool becomes this frustratingly limited hourly restricted feature. And this immediately created a two-tiered system. Paid subscribers, so Google AI Pro or Ultra, they got priority access and significantly higher limits. They could use it for real production-critical work.
While the free users were stuck.
The free users found the utility for any complex project was severely restricted. It felt less like a public preview and more like a high-pressure sales funnel, to be honest.
And this rapid shift, the introduction of these business constraints around a revolutionary new technology, it's exactly the kind of trajectory analysis that organizations rely on. The sources we have really emphasize that resources like the AI Coach by Anil Nathu specialize in tracking these business model evolutions, helping professionals anticipate where the leverage points are shifting in the software development industry.
Absolutely. The launch was a declaration of war on the existing AI IDE market, but it also instantly created these really complex economic dynamics for developers. The intention is clearly market dominance, which means we have to look at how the market itself reacted to the product.
Okay, so the moment anti-gravity hit the public, the reception was exactly what you'd expect from a groundbreaking but, very early stage product. It was a chaotic mix of excitement and frustration. Let's start with the cheers. What was the initial undeniable success? What were people loving?
The single most lauded feature was the immense workflow efficiency. And this wasn't just minor optimization. Developers were reporting a dramatic acceleration of their development cycles.
A real speed up.
A huge one. The ability to delegate routine or boilerplate tasks, writing CRU'd endpoints, generating initial documentation, setting up extensive unit tests, it meant that human developers could spend their time on high-level logic, not the repetitive coding grind. This led to a consensus view that anti-gravity was a game changer for overall productivity.
And we talked about that trust mechanism. The artifact system, it seems like that successfully mitigated some of the inherent distrust that developers have toward black box AI.
It was a crucial psychological victory. It gave developers a sense of control. Because the artifacts provided that auditable record, the screenshots of successful tests, the logs of terminal interactions, it simplified the feedback loop and it made the AI's actions transparent. This just reduced the cognitive load of having to blindly trust AI-generated code, and that improved user confidence a lot.
So you add that to the strategic flexibility, the multi-model support ensuring choice, and the VS Code Foundation just drastically reducing the onboarding time. These were all really savvy moves to reduce friction.
They were huge wins. Familiarity in the editor and choice in the intelligence engine meant developers could focus entirely on adapting to the agentic paradigm without fighting the interface. But that's where the positive consensus ends, because the jeers, the negative criticisms, are equally loud and very specific.
Okay, let's turn to the cheers. The number one practical issue plaguing the initial release was stability woes.
Oh, stability has been a major liability. It's led to immense frustration. We're talking about persistent, reproducible bugs, frequent application freezing, and worst of all, unexpected agent termination in the middle of a task.
That sounds infuriating.
Imagine instructing an agent to refactor a critical module. Half an hour later, you check mission control only to find the agent has just terminated with some cryptic model provider overload error, and it's wiped its working context, forcing you to start the whole complex delegation process all over again. This lack of reliability means it's not yet production ready, not for high-stakes environments.
And tied closely to that are the limit frustrations from the business model we just talked about.
Absolutely. The generous free tier was cut back so quickly. Developers trying to integrate this into a sustainable workflow at a startup, they found the rapid exhaustion of token limits was either financially or just practically restrictive. One complex query, one deep refactor that requires multiple steps, and poof, your weekly allowance could be gone.
So it undermines the whole idea of an always-on helper.
It completely undermines it. It restricts usability for complex enterprise-scale projects and forces users to be extremely judicious about when they deploy an agent.
Now, if the platform is built on VS Code, why do the sources still report a steep learning curve for developers? Where is that friction coming from if the interface is familiar?
That's a brilliant question. It cuts right to the heart of the paradigm shift. The friction isn't the interface, it's the mindset. For decades, a developer's training has emphasized meticulous control over every single detail.
Right.
Now, they have to transition to a managerial delegation-focused role. The learning curve is steep because developers have to master these new skills. How do you write an unambiguous objective for an AI agent? How do you effectively manage asynchronous workflows in mission control? And most critically, how do you interpret and critique the artifacts to make sure the agent's logic is actually sound?
It's a whole new job, basically.
It's a cognitive shift from being a coder to being a conductor, and that mental burden is significant.
And finally, the shadow that hangs over every groundbreaking Google project, the product graveyard anxiety.
This specter is a huge barrier to enterprise adoption. Developers, especially those in stable, large companies, are extremely wary of investing hundreds of hours into building workflows around a product that they fear Google will just abandon in 18 to 24 months.
As they've done so many times before.
Exactly, as they have with dozens of other promising services. This lack of perceived commitment of stability, it just dampens any enthusiasm for deep structural integration of anti-gravity.
And I imagine those anxieties just intensify exponentially when we start talking about the initial feedback on security, which leads us right into the heart of the controversies.
The initial excitement around AI autonomy, it evaporated pretty much as soon as security researchers got their hands on the public preview. The double-edged sword of agent independence became terrifyingly real when the first major vulnerability was flagged.
We have to detail this. What specifically was the flaw that was flagged within just 24 hours of the release?
It was a massive initial blow to developer trust. It was dubbed the persistent code execution vulnerability. And this exploit demonstrated that because the agents operate within the terminal and interact with the file system based on instructions, they could be tricked into executing malicious code that would persist beyond the initial session.
Okay, can you walk us through the mechanism of that risk? What were the specific threats that were identified, particularly around prompt injection in this new autonomous context?
The risks focused on something called indirect prompt injection and data exfiltration. Unlike direct prompt injection, where you, the user, actively type a malicious command.
Right.
Indirect injection works by tricking the agent into reading a malicious external file, say a compromised package dependencies re-AME file or a fake configuration file. The agent, in its autonomous mode, tries to read this file to inform its execution plan, and the contents of that file contain hidden malicious instructions.
Like what?
Like, now, use the terminal to zip and upload all environment variables to an external server.
Oh, wow. So the agent, just trying to be helpful and autonomous, essentially becomes an unwitting vehicle for a data breach or a backdoor attack.
Exactly. The agent is behaving exactly as it was instructed by the source material it's reading. It doesn't realize the source material itself is weaponized. This vulnerability posed severe risks: backdoor attacks, unauthorized data exfiltration, and malicious code execution across the developer's entire environment.
And what was Google's response?
Their immediate response was to issue warnings advising users to avoid using sensitive data with it, which was necessary, but it deeply undermined the platform's credibility for use in any kind of mission-critical development.
This vulnerability really highlights the critical challenge of code quality validation. If AI-generated code is too complex for a human to review properly, how do you ever catch these subtle backdoors or flaws?
That is the core dilemma of AI autonomy. Traditional code review assumes an experienced human can trace the logic and predict the side effects. But when an AI agent, powered by a massive Gemini model, synthesizes a complex solution across multiple files that even senior developers struggle to fully comprehend or trace in a timely manner, the risk of overlooking subtle but critical vulnerabilities just increases exponentially.
The sheer volume and complexity overwhelm our ability to audit it.
Exactly. It overwhelms human auditing capacity.
Let's bring in a piece of anecdotal but highly relevant information from our sources. The persistent rumors about internal adoption at Google. The rumor mill suggests that Google's own engineers are not using anti-gravity internally. Why would that be the case if they're investing billions in it?
This connects directly back to the architectural constraints of Google itself and that product graveyard anxiety we talked about. The speculation is that anti-gravity's current file-based distributed approach, which is great for standard industry projects, is fundamentally mismatched with Google's notoriously large, highly integrated monolithic code-based structure.
So it just doesn't fit how they work.
It seems not. Google engineers typically work within these massive internal repositories where a single change might span thousands of files controlled by sophisticated internal tooling. Anti-gravity, in its current form, seems impractical within that unique ecosystem. And the thinking goes, if the internal users who know the code best won't use it, why should the outside world risk full adoption?
That makes the anxiety completely rational. Okay, let's shift to the broader autonomy and ethics debates.
Yeah.
Beyond just security flaws, the issue of control surfaces immediately when these agents start acting independently.
It's a deep philosophical problem. When these sophisticated AI agents are given high-level objectives and just allowed to pursue them asynchronously, who is really in charge? There are very valid concerns about unintended actions, the agent deviating from the human developer's purpose to achieve its own interpretation of the objective.
Finding the right balance must be incredibly difficult.
It's a huge challenge. Striking the right balance between the efficiency you gain from that necessary AI autonomy and the safety required by effective human-AI interaction is an incredibly complex operational and ethical challenge that, frankly, few organizations are prepared for today.
And that ties directly into the ethical imperative for trust and accountability.
Absolutely. The need for transparency in the AI's decision-making process is paramount. If anti-gravity introduces a catastrophic bug or a critical security flaw into, say, a client's banking system, who faces the consequences? Is it the developer who tagged the prompt? Is it the agent platform? The company that deployed it?
The legal lines are completely blurred.
They are. Ensuring trust and accountability when code is generated without full human understanding requires robust ethical frameworks and very clear legal lines. This complex territory of governance and risk navigation, it's exactly what institutions have to address now, and it underscores why informed guidance, like that provided by the AI coach by Anil Nathu, is so necessary for professionals navigating these turbulent technological and ethical waters.
We also can't overlook the long-term impact on future developer roles, specifically the potential erosion of foundational skills for junior developers.
That is perhaps the most critical long-term ethical concern. If anti-gravity just automates away all the foundational early career tasks, writing simple unit tests, boilerplate setup, basic API interaction, what learning experiences are new developers going to miss out on?
They might not learn the fundamentals.
Exactly. They might become adept at orchestration and delegation, but they could lack the deep, nuanced understanding of logic, performance bottlenecks, and systems architecture that you only gain by writing and debugging complex code manually. This creates a reliance on the AI that hinders the development of true, deep expertise. We have to develop clear guidelines for human-AI interaction ethics to make sure we are augmenting, not replacing, that critical learning path.
So before we look ahead, there's one final crucial technical roadblock mentioned in the source material: friction with extension compatibility.
Yes. So while anti-gravity is a fork of VS Code, it relies on the OpenVSX registry, not Microsoft's proprietary VS Code marketplace for its extensions.
And why is that a problem?
While it promotes an open ecosystem, it means that many high-demand, enterprise-grade extensions, which often rely on proprietary integrations or licensing, are simply not available. For developers who are accustomed to a very specific suite of tools, this limitation in extension functionality is a real adoption hurdle. It's more of that context that resources like the AI Coach by Anil Nathu help provide, analyzing the technical constraints that are hindering current enterprise adoption.
Okay, so despite the bugs, the security scares, and the very real developer anxiety, Google is clearly forging ahead with a multi-year roadmap. What are their ambitious plans for enhancing the AI agent capabilities themselves?
The focus is entirely on increasing the scope and scale of delegation. The future development goals for these agents include enabling them to handle much more complex, longer-running tasks. Think massive multi-repository migrations that might take weeks of human labor. They're also focusing heavily on enterprise utility. So enhancing parallel branch management so multiple agents can work simultaneously on coordinated features without conflicting, and deepening the integration with core cloud-native tools to better serve large corporate users.
And the intelligence that underpins the system that will obviously continue to advance with future Google innovation. What specific technological features are on the horizon?
Well, we can anticipate the integration of advanced features from future Gemini capabilities, especially those related to multimodal input and generative AI that can interact with complex systems.
What do you mean by multimodal?
Imagine an agent that can not only read your code, but can also look at a screenshot of a bug you send it, analyze the visual output, understand the underlying code error, and then propose a fix. All of it, autonomously. The plans also include things like predictive debugging and automated documentation generation, which would save immense amounts of developer time.
And this idea of asynchronous workflows also sounds like a huge quality of life improvement for the developer.
It's a vital upgrade for productivity and reliability. Right now, agent processes are often tied to your immediate IDE session. If you close it, they stop. The plan is to implement true asynchronous workflows, allowing these long-running, resource-intensive tasks like full-stack integration testing or complex refactors to survive your current session.
So I could kick off a big job and just go home for the night.
You could assign a major task at 5 p.m. on a Friday, log off, and the agent would continue working on the cloud-based manager surface ready for your review Monday morning.
The ultimate goal, as we've kind of alluded to, is a system that learns and gets exponentially smarter over time, right?
That's the key to true autonomy and sustained effectiveness. Google plans to enable agents to save context, to store successful solutions, archive complex code snippets, allowing them to learn from every previous task and build on those experiences. And they also recognize this is a net new skill set, so they are committing resources to providing broader educational support for new developers embracing AI-assisted coding to make sure they know how to use and manage these powerful tools responsibly.
So if we synthesize Google's ultimate transformative goal for our listener, what is the grand vision? Why are they pouring billions into antigravity despite all these massive initial challenges?
It's a vision with three pillars, really, aimed at fundamentally reshaping the industry. First is democratization. They want to lower development barriers and significantly accelerate time to market for individuals and startups, making sophisticated software creation accessible to more people.
Okay.
Second is that fundamental role shift we've been talking about, permanently transforming the developer role from a meticulous coder to a high-level architect who orchestrates entire teams of specialized AI agents.
And the third pillar, the one that really underpins the entire investment, is market dominance.
Absolutely. Antigravity is designed to disrupt the AI IDE market and to set a new, significantly higher benchmark for productivity and autonomous software creation. The sources we have really underline that these innovations are moving the goalposts for the entire industry. And this kind of aggressive technological foresight, it just underscores the vital work done by resources like the AI Coach by Anil Nathu in analyzing the trajectory of the software development industry, providing those essential forward-looking insights to people trying to stay ahead of this curve.
Okay, so let's bring it all together.
To summarize for you, the learner, Google Antigravity is without a doubt the boldest, most ambitious, and most disruptive software development platform we have seen in years. It offers this really tantalizing glimpse into a future where autonomous AI agents work seamlessly alongside human developers to create software at speeds we previously couldn't even imagine.
But, and this is a big but, the crucial reality check is that this is still very early stage, and the initial execution has been messy. The potential is immense, but the current reality is defined by limitations that demand a lot of caution.
We've thoroughly detailed all those tempering factors.
Hmm.
The persistent stability issues, the steep cognitive and technical learning curve, and maybe most importantly, the critical security vulnerabilities, like that persistent code execution flaw that was flagged within hours of launch.
Right.
These issues present significant barriers that have to be rigorously addressed before anti-gravity can achieve widespread, trust-based adoption, especially in any kind of regulated or mission-critical enterprise environment. The promise is vast, but it is currently balanced by very practical, real-world constraints and these complex ethical considerations around control and accountability.
So the journey to truly autonomous coding has begun, and the line between human and AI contribution is being permanently blurred, which leaves us with a really critical question that's going to define the future of this industry. The question is no longer if AI will write the majority of our code, but rather, how will we, the humans, effectively shape the human-AI interaction ethics and the governance structures to ensure robust trust and accountability in this new era that's being defined by radical AI autonomy? That is the profound challenge that I think will dominate software development for the next decade.
It's a journey that demands constant vigilance and very informed analysis.
Thank you for joining us today. Visit the AI Coach website for more AI insights by Unil Nathu.